NCM Learning Center.
Good morning friends. In this video we are going to discuss about the bridge circuit concepts and problems for measurements. We will discuss the full detailed AC and DC bridge circuit concepts. First we will discuss the concepts, then we will solve the problems from the standard exam questions. First you should know the name of the bridges and its uses. Wheatstone bridge is used to measure the medium resistance. Medium resistance means the range from 1 ohm to 100 kilo ohm. Foster bridge, medium resistance measurements. Kelvin's double bridge, very low resistance. Very low resistance means less than 1 ohm. Loss of charge method, high resistance, above 100 kilo ohms. Mecker means insulation resistance, IR value measurements. These are the DC bridges. For the AC bridges, Maxwell inductance bridge, inductance measurements, but not suitable to measure quality factor. Then Maxwell inductance and capacitance bridge, inductance measurements. The Q range is less than 10, higher than 1, medium range. For Hayes bridge, inductance for high Q range when Q greater than 10. Anderson bridge, inductance measurements, it will give the accurate result, quality factor Q less than 1. Owen's bridge, inductance measurements, suitable for very low range. Okay. Then Heaviside bridge, mutual inductance. Campbell's bridge, mutual inductance. The Campbell's bridge is a modified form of Heaviside bridge. Okay. Then DSRT bridge, capacitance measurements. Shearing bridge, capacitance measurements. Vane bridge, mainly for frequency measure. Okay. In the competitive examinations, the one more questions may asked. What is the use of the bridge? Okay, you should know this list. Now we will discuss the concepts. AC bridge circuit concepts. So this is the bridge. Here amp resistance Z1, Z2, Z3, Z4 are the amp resistance. 4 amps. So let us take the node voltage. Here this is V1, V2, V3, V4. The source voltage is Vs. Okay. The source Vs is directly connected between V1 and V3. Directly connected. So V1 minus V3 is equal to Vs. Vs means voltage across V1 and V3. So V1 minus V3 is equal to Vs. This is a positive side. This is a negative side. So we may take V1 as Vs and V3 as grounded. So it is equal to 0. Now at balanced condition, current flow through the detector is 0. Balanced condition means the current flow through the detector is 0. So voltage across the detector is 0. Current 0 means voltage also 0. Vs V is equal to IR. Okay. So if current flow is 0, V2 and V4 will be same. Okay, because voltage across the detector is 0. So V2 minus V4 is equal to 0. We will get V2 is equal to V4 is equal to VA. Now we may replace the circuit diagram as here. Here V1 as Vs, this V3 is as grounded, this V2 is equal to V4 is equal to VA. Now the unknown parameter is only one node, VA only unknown. All these are known parameter. Vs is source voltage known, the ground 0 volt. So unknown parameter is only one node, VA. So node analysis is very easier for the bridge circuits. If we use the mesh analysis, it will be very difficult. So if the questions are asked, we got to find the current flow through the detector or current flow through the this amp resistance, we should use the node analysis. So already we discussed how to find the current for the bridge circuits. So that video link is attached in the description box of the video, just refer. So here what is the level of current IA? IA means Vs minus Va by Z1. Okay. So basic Ohm's law. So this current IA is equal to Va minus 0 by Z3. Both are same. You get this, so we will get Vs. Let us take this equation as 1. Now find IB. IB is equal to here Vs minus Va by Z2. Okay, this current IB, Va minus 0 by Z4. This both are same. Equate this, we will get this. Let's take this equation as 2. Equation 1 and 2 are same. So equate this equation 1 and 2. We will get Z1 into Z4 is equal to Z into Z3. So opposite arm resistance Z1 and the product of opposite arm resistance is equal to product of other arm resistance. Here this are opposite. So Z1 into Z4, other product Z3 into Z2. So we may conclude that at the balanced condition of bridge, the product of opposite arm resistance is equal to product of other opposite arm resistance. Okay. But if Z1 value is equal to Z1 in angle theta 1, Z2 is equal to magnitude Z2 phase shift theta 2. Similarly for Z3 and Z4, at balanced condition, the magnitude is equal to Z1 into Z4 is equal to Z2 into Z3, but phase theta 1 plus theta 4 is equal to theta 2 plus theta 3. Because if you multiply the two phase angle, the resultant will be addition. Okay, so this is the balanced condition of the bridge. We should remember this formula. Okay, now we will discuss the problems. The first questions. This question is asked in GATE 20 instrumentation exam questions. We have to find the quality factor of the coil. First, we should know the reactance of XL basic. XL is equal to J omega L, X is equal to minus J omega C. Quality factor. Quality factor of the coil Q is equal to omega L by R. XL by R. Reactance by resistance. If you know the LX value and RX value, we can find the quality factor of the coil. For circuits, we cannot use mesh analysis or node analysis. We have to use the balanced condition. Because confluent detector 0 means balanced condition. So let us take this impedance, the combination of R1 and Z1, parallel combination. This is a Z1, this is a Z2, this combination of R and L is ZX, then Z2. Let us take. We know that at balanced condition, the product of opposite arm resistance Z1 into ZX is equal to product of other opposite arm resistance Z4 and Z2. Okay, this is the balanced condition. So another one condition, phase shift condition, theta 1 plus theta x is equal to theta 2 plus theta 4 only. Okay. So first find Z1. The Z1 is a combination, parallel combination of R1 and XC. XC means minus J by omega C1. Here C1. This is parallel. We know that parallel combination. If two resistance are in parallel, the resultant will R equivalent is equal to R1 into R2 by R1 plus R2. Okay. So we will get this. This is R1, this is X1. R1 and X1 divided by R1 plus X1. Okay. Resultant of the parallel combination. Now simplify this equation. We will get this. This is the Z1 value. Now find Zx. These are in series. If the two resistive elements are in series, you will get addition. So Zx is equal to Rx plus J omega X. Okay. Now Z2 only R2. So Z is equal to R2. Here Z4 only have R4. So Z4 is equal to R4. Now substitute these values in the balanced condition of this equation. You will get this. Okay, this is Z1, Zx is equal to Z2, Z4. Okay. Remember that in the simplification, denominator term should not have the imaginary term. The denominator terms in the left hand side will goes to the numerator terms of the right hand side. So simplify this equation, you will get this. Now separate the real term and imaginary term. This is the real part. This is the real part. Omega Lx into R1 is equal to here. This is the real part. This is R1, R2, R4, R1 omega 0. Okay. Now omega will be cancelled. R1, R1 will be cancelled. We will get Lx. Coil inductance will get Lx equal to R2, R4 into C1. Similarly, equate imaginary term, imaginary part. Here imaginary part is R1, Rx. Here imaginary part is R2, R4. Okay. So Rx is equal to R2, R4 by R. Okay, now the unknown resistance and unknown inductance calculation is over. We go to find the quality factor Q. Substitute these values in this quality factor equation, will get the answer is omega R1 Z1. So substitute value Q is equal to omega Here this omega value is given here. Root 2 cos omega t. This is omega value. Omega value 1000. R1. R1 means 100 kilo ohms. 100 into 10 to the power 3. C1. C1 means 100 nanofarad. So 100 into 10 to the power minus 9. So we will get 10. So the quality factor of the coil is 10. Okay. Good. Now another one problems. This question is asked from Indian Engineering Service 2021 prelims electrical examinations. Okay. So the bridge concept is important for electrical ECE instrumentation students. Okay. The objective of the question is we have to find the element Z4, unknown element, whether the Z4 is purely resistive or RC, RL or parallel. We have to find. Remember that if phase angle Z4 is positive element means phase angle is positive means the element will be RL element, resistive and inductive element. If phase angle is negative means it is a capacitive element, RC element. If phase angle is 0, purely resistive element. If phase angle is 90, exactly 90, then it is a pure inductive element. If phase angle is exactly minus 90, then the element will be a pure capacitive element. Okay. So if you find the phase angle, we can judge which element is here. So we know that it is balance condition. At balance condition, we know that Z1 into Z4 is equal to Z2 into Z3. Okay. Phase angle shift theta 1 plus theta 4 is equal to theta 2 into theta 2 plus theta 3. Okay, this is a balance condition. So if you know the theta 4 element, theta 4 value, we can identify the element. So theta 4 is equal to theta 2 plus theta 3 minus theta 1. Here values are given, phase angle values are given. Here theta 1 is equal to 60, theta 2 is equal to 0 degree, theta 3 is equal to 30 degree. The values are given. Substitute here. So we will get theta 2 0, theta 3 30, theta 1 60. Okay, we will get minus 30. Theta 4 is minus 30. If it is minus 30, it means that a positive element, it has some resistance. So RC element. So option B is correct. Okay, this is the concepts. Now for do it yourself, I will ask 5 questions. You should solve these questions. Pause this video and solve all the questions. Check your answers with our answers. If you have mismatch answers, just comment your answers with the comment box of this video, or otherwise comment your answers in the our WhatsApp group. Okay, definitely you will get this solution. Okay. First question from GATE 2022 instrumentation exam questions. We go to find the L3 value. Okay, second questions from GATE 19 instrumentation exam questions. We go to find the dissipation factor D is equal to 1 by omega Cp into Rp. If you find the Rp and the Cp value, we can find the dissipation factor. Okay. Third questions from GATE 17 instrumentation exam questions. Okay. If you understand the discussed concepts very clearly, you can solve this problem easily. Okay. Then fourth questions. The fourth questions from GATE 2014 instrumentation exam questions. The fifth questions from Indian Engineering Service 2022 prelims electrical exam questions. Okay. Just solve the 5 questions. Our answer is for the first questions answer is 14.50. For the second question is 0.042. Third question is 10,000. Fourth question is R and element. Option B. For fifth question, option B is correct. Okay. If your answer is mismatch with your answers, just post your doubts in our comment box or WhatsApp group. Okay. Good. Thank you. Visit our website www.ncmlearningcenter.com. You can get the video materials for GATE, IES, ISRO and other competitive examinations. Then PDF materials, PDF book materials prepared for NCM Learning Center. If you use this material, definitely you can get the good marks in the competitive examinations. Then you can get the test series. Join our WhatsApp group, NCM Learning Center WhatsApp group. That link is attached in the description box of the video. Join in our group. If you have any doubts related to the discussion, just post in the WhatsApp group. You can get the solutions. Okay, good. Thank you.
Thanks for watching. Click the subscribe button and click the bell icon for notification. Like, comment and share.